All right, so this talks about lighting, and lighting's one of the more difficult parts about graphics rendering and across the board, not just in Unity. So it's easy enough to get lighting on an object. If I look at the light on the carpet, I can judge where the light source is and where I am and how bright the light's going to be. But when we start thinking about light bouncing through the room, we have light coming in, diffuse through the wall there and bounces off there, and it starts getting very difficult to figure out how bright something should be. And this is why in the movie industry, you send something off overnight and it does raycasting and figures out the lighting for a situation. So how do we do that in real time? Traditionally, we've either done completely real-time lights, where you do just what I described before. You just calculate where lights are and where I am and have a guess. Or you bake things. And I'm going to show you both of these, but just to get the terminology down. Or you bake something. So I do some calculations when the game's not running, bounce light around a little bit, and then actually write light data into textures, so I don't have to calculate it at runtime. So traditionally we've had real-time and we've had baked. I'll show you those in just a second. But now we've got a number of modes in the middle that help us adjust performance. So this talk really is on two levels. One is we've got these extra modes as a game developer or an app developer or whatever I'm doing. How do I choose the right mode for me? I'm going to give you a cheat sheet at the end and a bunch of references. And we'll go through, I'm going to look at each of these scenes in turn, look at each of these modes, and I'll show you the advantages and disadvantages of both. So you can take that away with you at the end. But just because I'm into this stuff, I'm also going to show you the techniques behind that and how this light's actually working and how it's getting the results. I enjoy that, but I also think it's important if you understand the techniques behind, you understand then, oh, why don't I get specular in that certain situation, for instance. So if you're into that, you'll get that out of it. If you just want the cheat sheet, just let some of the stuff wash over you and just have a look at each scene and what works and what doesn't work. So I'll start by showing you the real-time and the baked light situation. So let's jump into real-time. So this is my real-time scene. Let's press play. So this is good lighting quality. The quality of things we're going to look at as we compare these scenes to each other. We're going to look at the specular. So you can see these cars go a bit shiny when they come through here. We can see some shininess on the bin. So we get specular light. There's two light sources in this scene. One is this lamp post in the middle. And the other one is we have a big directional light coming from the top. That's the one casting these shadows onto the road. So we're working with two light sources. Oh, I lied. Actually, that police car has two lights on top, but we'll ignore those, all right? So the other thing we want to look at is shadow quality. So when we see a car driving up this way, have a look at how the shadow goes on its roof. And we'll just wait for it to pop up. So you can see we've got a nice clean shadow on the top. So this is real time. There's a couple of techniques I'll show you that we do to get nice quality lighting for this. And this is the most expensive situation. So this is the one that costs you the most to get the best quality. How do we actually do this though? How does this work? One is, like I mentioned, the direct light's easy when it's shining on something. Indirect's harder. So how do we do that in real time? So we use light probes. So in our scene, we have all these spheres. In our scene, you can see all these yellow dots. And what they do is they actually capture lighting information, indirect lighting information in our scene. Sometimes that will change over a number of frames, so it will adapt to being real time. So as you change lights in the scene, they will slowly change, but they don't change in exactly real time. But they capture some of the indirect lighting information. So when we're doing, in this scene, the indirect lighting, so for example, when the light bounces off the pavement and goes up against the shop, some of that's going to be calculated using light probes. I have this lighting settings dialog up here. The only thing I have switched on here at the moment is real-time global illumination. So that's the bit that does this indirect lighting with light probes. Okay, so that's one. That's the indirect lighting thing. But how do we actually do shadows? Well, I want to show you the frame debugger to show you how that does that. So we have a frame debugger. It's just a window here. You can find it in the window menu. I'll enable it, and this is really awesome. So what this does is it actually shows you all the graphics calls for a single frame in your game. So if you want to understand exactly what's going on, you can dive into this thing. Or if you find that something's not working as expected, if you want to understand the difference between forward and deferred, jump in here and have a look at exactly what is going on. So I'll fold up all these things here. We just do some initial depth rendering. and fold up all this here just to get the main steps. So when we're rendering our geometry, the first thing we do is render a shadow map. So the shadow map is the technique we're using here. A shadow map is the scene rendered from the point of view of the light. Now remember, we have one big directional light that's shining down on everything. That's what it sees, and it takes the depth information of that. So what that means is, the issue we have in this scene is when the road's being rendered, we're just rendering that particular object. It doesn't necessarily know which objects are around it and whether it's in shadow or not. So what it does is, as it's rendering itself, it looks at that shadow map and says, is something between me and the light? And that information is in that shadow map, right? Because it can see what the light can see. If it is, well, I'll draw a shadow. If not, I won't. So there you are. That's the basics of that's our real-time lighting. And again, that's the techniques. If they don't make sense to you, don't worry. You don't need to know them, but it helps later on when we go through all the different techniques. Yes?
Can I just ask about the efficiency? Because I thought the lighting probes, I'm not sure how they capture the lighting. I thought that was a texture-based kind of thing. It looks like there's a lot of lighting probes.
So yes, it would be more efficient if you switch them off. So this is kind of the most expensive situation, and so it is capturing information as the game's running. It's not necessarily a straight image. It's spherical harmonics and other maths that I don't understand, but it does capture effectively an environment around it, or a spherical environment around it. So that will have a cost, yes.
Maybe not as bad as rendering the whole scene, like the shadow.
Well, I mean, this is the most expensive solution. So if you turned it off, you just wouldn't get that diffuse. You wouldn't get the indirect lighting, like the light splashing against the shop. So you get poorer quality lighting if you turned it off, but for more efficiency. Yeah.
Right.
So let's look at the other extreme now. Fully baked, which sounds like, I don't know. I won't go there. So this is the fully baked scene. Now again, we're comparing the scenes. I'm going to have the same scene from the same perspective every time. You might already notice some of the things I pointed out the first time are missing. What are some of the things that are missing? Anyone? Shadows in the cars. So this shadow here is actually part of the texture, part of the road texture. I'll visualize that for you in a second so you can see it. That lamppost, the light there is actually not there, right? Any light that we've baked, it actually doesn't exist in the scene when we're running it. So the only lights that are actually here are the cop lights, they're still there. But the main directional light and that lamppost aren't there. Everything is just textures, okay? So what that means is, yes, there's no lights, so there's no shadows on these dynamic objects. So therefore, there's no specular on the car either. There's no specular on the bin. Let's wait for the car to pass up here and see what it looks like. Oh, did you see that ugly flashing on the car? I'll let it go again. Keep your eyes peeled for that. What's that about? So we've purposely created a worst case situation here for the lighting. I'm going to let it come up again just in case you missed it. Look, that thing is flashing. Looks really ugly. We don't have that same shadow information. If I showed you the frame debugger now, the shadow map would be empty, except for the cop car. So how do I put a shadow in a car? Well, I use light probes again. But the light probes are an approximation. And so as I travel and flip-flop between those two light probes, I'm just making a guess at where that shadow is. I get really low-quality shadows, and if you get something moving, it can move. I've got this boundary line there on purpose, so I'm just kind of on the edge there, and I get that worst-case result. For the visual people, I will show you what that looks like. Well, in the scene view, there's this handy little drop down here that shows you a whole bunch of debug views of your scene. This view here is our baked light map. So as I said, things are in textures now. So this is what those textures look like. You can see that light on the ground, and you can see the shadow. These are the textures that are applied to the road. The other way to visualize this is and you can see, we'll be able to see some of the splashback as well on some of these things, some of the indirect lighting. So in that corner there, it's a little bit brighter. So everything's baked there. If I go into the lighting tab again, I can actually, this is another view of those textures as well. It's baked, these that we call the maps, but the textures. This is the lighting data, and we also have directional lighting data as well, but I won't go into that there. But we've got these extra textures, just so you can visualize what that might look like. So that's the most efficient, because we don't have to do any calculations, but it kind of sucks, right? So What this might be good for is if you have some fill lights that you don't necessarily want them to cast shadows, you just want them to kind of add to your atmosphere a little bit. You could bake those in there and it's no big deal. Or if you're lucky enough to have an extremely static scene where things aren't moving around, then you can bake to your heart's content.
Is that what the light you have on fake photo?
Yeah. Nice one. I'll show you that. So we have this new window here called the Light Explorer. I'll show you what these mean. So I could go click on these in the hierarchy and find them back here, but it's just got all my lights in one little list for me to make it easy to see what they're on about. These top two here are the cop lights, and they're real time. So if I drop this mode down here, I've shown you real-time lights, and I've showed you baked lights. So to swap between the two, you just pull that drop down on your light down, and it'll start baking it for you. The bit I'm going to show you now is the one in between, which says mixed, and that's when we start to get some other techniques. So let's go on to the next mode. So this mode here is called subtractive. And if people, we did have a mixed lighting mode in Unity 5.6 and before. If people have used that, that's what this is. This is the old, if you like, lighting mode, and it's called subtractive. Have a look at those quality points I mentioned. What do we see? The flickering is still there, yep. We get some specular now, which is nice. So there's some specular and dynamic objects. So you can see the car's shining, the bin's not. If you have a look at the shadow, you notice there's only one. We don't get any shadow from the lamppost. So we only get one shadow. So the difficulty here is if we want to start going between baked and dynamic, well, we have all our shadow data in a texture, and then we have this car that's also cast in a shadow. How are we going to mix those two together? How do we deal with that? That's the biggest issue here. And what subtractive mode is a way of doing that. Let's have a look at the light settings for that. So as soon as I turn my lighting to mixed, then I get these options pop up here. So I've got my lighting mode set to subtractive, and then I have this real-time shadow color that pops up here. And this is actually the color of the shadow that's going to be passed through, and the shader is going to recognize that color and then do its best to mix the two. It's going to try and subtract out the baked-in light and use this light instead, or merge them together somehow. It only supports one light shining, and it's not PBR friendly because it does this extra shader stuff to mix shaders together. But it's still pretty efficient. So you could still use this in a game if you had a simple game with one main light and the shadows didn't, sometimes these shadows don't work great. If the shadows are looking good, you only have one light that you want to do and you're really concerned about performance, maybe you're on mobile, then this is still a legitimate mode to choose. But we've actually added some other modes in here as well to get a little bit fidelity on that. So move to the next mode. So this is the next big technique I'm going to show you. This one here is a shadow mask. So mind you, I've shown you shadow maps already. That was one of the frame debugger. Now we've got shadow masks. So they're named very similarly, so don't get confused. But this one here, this is our next mode. So what do we see? We have specular on the car. We have specular on the bin now as well, which is good. And look at the cars. The cars have two shadows. So we brought back some shadows here. We're still going to get our ugly flickering here when the car comes up. So, oh no, that actually looks pretty good. We don't get our ugly flickering there. Ignore me what I just said. So what is this technique? What are we doing here? It's fairly straightforward.
Masking.
What's that?
So we are masking, I think.
Yes, shadow mask. So you notice here we've got a third column. The third column is our shadows, but all we've done is instead of baking our shadows directly into our light map, we're putting them into a different one. So we have a light map, which just has to do with lights, and then we have a shadow mask, which is just to do with shadows, and that lets us then blend shadows together, because I can look up a texture to find out what the shadow is, and then I can look at my dynamic shadow and blend them together, and I don't have to make a guess of what's happening in the light map. So What this means, if you're making a game you don't care about all that, is that it's slightly less efficient again because there's an extra texture lookup, but it solves a bunch of the issues that we had before. You can have up to 4 lights here. You notice people are used to working in textures and maps. We often think about channels, so you've got 4 channels in your texture you can work with, so you can have 4 lights overlapping and it'll calculate the shadows for it. So let's have a look at our debug stuff again. So our baked light map. So it doesn't have, all it has now is the indirect lighting baked in. So the lighting actually is happening in real time, and the shadows are coming from the shadow mask. I'm going to pop up the slides for a moment. Hopefully PowerPoint doesn't crash again. So just to summarize that sort of stuff, baked is the most efficient, but you don't get the shadows. Subtractive, I looked at already. I forgot to mention it only works in forward rendering mode and gamma as well, so it doesn't work in linear and deferred. And you only supports 1 light. Shadow mask is the one that we're looking at now, and the shadows are stored in a separate shadow mask object. So it means that we get better shadows at a cost of an extra texture lookup. And it's PBR friendly. So now you can get all your PBR shaders working as well. I will give you these slides as well. One addition to that, it's not really a new mode, is distance shadow mask. So I've gone into the quality settings here. And, oh, that's what I've done. That's what I've done. I had distance shadow mask on. So let's watch my flickery car. I want to be proven right. Or it's going to be, am I going to be proven right or wrong? It's going to be a massive embarrassment. Come on, car, don't leave me hanging. There we go, it flickers. I just had the wrong mode on. Sorry, people. So that's, so we have shadow mask. And then what I can do is I can drop that down in the quality settings and change it to distance shadow mask. What that does is that technique of shadow masking, what it's going to do is it's going to apply it to objects in the distance. Anything that's beyond this shadow distance. So, and it's going to apply a higher quality lighting to closer objects. So this is where you can balance between. If you have a large world, you can have a cheaper light on things that pass your shadow distance, this subtractive, this shadow mask technique. And then for close up, you have all the real-time lighting, which does everything you want. So there's a performance balancer. And then the last one, which is the closest to real time, is baked indirect. This is quite similar. My light map only has baked lighting in it. And everything else is real time. So exactly what I showed you in real time goes on, except we have indirect lighting that's baked into our scene. So what this means for you is, if you move a light, the indirect lighting will be wrong. You can change its color, you can do all that sort of stuff. But if I'll show you again this debug view, so we have, say, the splashback along that shop there of the white light reflecting off. If that lamppost was in a car accident and went away, then you'd still have that white light there, and that might look a bit odd, or if you're moving lights around. So again, it's a choice about where you want to move. You get some extra light fidelity. You don't have to use the light probes to get that indirect light. You can bake it into your scene, but you still have restrictions to what you can do with your lights. So yeah, so there we are. So there's the light modes I quickly ran you through. Again, the idea is not to teach you everything about it, but just to give you an idea that when you're doing your next project, what should I choose and what are the guidelines for that, just to know that they exist. Because otherwise you'd sit there going, what's subtractive? I don't know. And so these are kind of, it depends on the game, but they're kind of in order of efficiency. So baked being the most efficient, real time being the most inefficient. Subtractive being the next, shadow mask, distance shadow mask, and baked indirect. So subtractive being the old mode that only supports 1 light and is not PBR friendly. Shadow mask being the new mode with PBR friendliness and up to 4 lights. And baked indirect being almost real time. Let's have a look at these cheat sheets. I just remembered I didn't bring them up afterwards, so let's see what happens if I click Chrome. So again, these will come out in the email. You don't have to take these down now, but I just want to show you how they work because there's a table that needs a little bit of understanding to how to read it. Let's wait for the things to kick in. So one is the documentation. The documentation for lights is actually pretty great. It goes through some of the theory that I've just told you about. If you're confused about any of that, it's worth reading through and going into that. It's got all these sections on the side and mixed lighting and real-time lighting, what it is. The cheat sheet is actually just the project I showed you today with arrows and numbers to say, here's the bit that's missing and here's the bit whatever. So if you kind of thought there was a big wave of information, you can go back and look at, oh, 4 means there's no specular on the bin, and that's because I'm in this particular lighting mode. So that will help you choose a light for your project as well, because you might really want specular or certain sort of shadows, and you can go and choose that way from that point of view. And the last one is this reference card. So this is if you were into the techniques I just talked about and you understand how they work and you want to choose a lighting mode based off that rather than the visual appearance. I'll break it down for you a little bit. So this top section here is what type of light we're using. The bottom section is how we do shadows. So let's take an example. If I'm using the shadow mask technique over on the side there, and the receiver is for direct lighting up the top there, that means the receiver will use real-time lights. So if it's a static receiver, so the Rode or something like that, then it will use a light map. So it just breaks down the techniques one by one. Same thing for shadows. This top section is just kind of like a key for the table. Let's take the same example. If I use a shadow mask and I have a dynamic object that's casting a shadow like the car, and I have a static object receiving that shadow, the road, then I'm going to use the shadow map to create that shadow.